I've been watching this thing go up and down. This is a 10 by 10 room. It's got a built-in baseboard heater. And when the baseboard heater is on, right now it's still on. As long as the baseboard heater is on, this thing goes down in frequency. As soon as the baseboard heater switches off, this thing starts creeping back up in frequency. So one of the things I had trouble with working with the Franklin is deciding how much does the oscillator actually drift itself, or how much does the room temperature affect the circuit. Now, the room temperature in a 10 by 10 with a small space heater, you can actually feel the room get cold. And then when the space heater kicks in, after a few minutes it gets quite warm. So right now she's dropping in frequency because this room's heating up. But I'm realizing that my PTC idea wasn't so bad, but I got a feeling the PTC, remember that's that thermistor, that self-regulating temperature? I got a feeling it was placed in the wrong part of the oscillator, or it itself it varies more than I expected it to get better results. In other words, you figure it would hold the temperature inside that metal box within 1 degree. And maybe 1 degree makes this oscillator move a lot more than I expected to. See, it's all scientific method. It's a matter of, do I stay with it and try to figure this out? And I told you, if you go look in the internet, nobody will tell you that the oscillator will drift 100 hertz between variable temperature in a room. Now, this is a small room. This heats up and cools off very fast. So if you had a bigger room and a better temperature regulation system than a one baseboard heater, the Franklin oscillator will be a lot more stable. But it's fun watching this thing go up and down with the room temperature. And when I had the other unit in the metal box, it didn't seem to help at all. And I'm suspecting that I used an aluminum box, and the aluminum box sheds its temperature very quickly. What I probably should have used was a steel box, a thick steel box. That's what a lot of the people used on the internet when they started making these ovens and stuff. The aluminum, I don't think is going to be any good unless you make a real good temperature regulator that goes in the box, or maybe line the aluminum box with some styrofoam. That's maybe my next step. But as I went through the internet, all I found was the people that used a steel box. I used a metal aluminum box because it's what I could bend, and I wanted to see. I don't know the difference between, say, a steel box and an aluminum box, because no one ever published it. No one ever said use a steel box, because if you use an aluminum box, it changes too quickly with the temperature. Now this room is a dead giveaway with the way, like right now, the heater's still on, and it's quite warm in this room. And my thermometer is not the greatest thermometer. It's not digital. It's an old alcohol type one, and to see 2-3 degrees change on that, it's quite tough. But I just want to update this more. It definitely, what makes this go up and down is definitely temperature. It would be nice to have a better controlled temperature. I was hoping that PTC was going to do it for me, and then I can give it. But right now, at near 6 megahertz, let's see, for it'll be 60 up there, 20. We're still under 100 hertz, way under 100 hertz for drift, which is better than the PTO that comes with the Collins. So using a solid state Franklin oscillator is still better than a temperature controlled PTO. And if I could get the room to regulate its temperature better, I would have better results too. But little by little, I do a few experiments on it, and I'll pass it along to you. I think that's it for now. All right, that's it.